Hello, Tuskegee University students. This is Dr. Gerald Griffin. Today, I will be addressing key points related to chapters 9 and 10 in your PERS et al. Neuroscience textbook. But before going on to discuss particular chapter content, I would like to bring your attention to the disorder fibromyalgia. Fibromyalgia is a main chronic pain condition in which patients experience exacerbating muscle pain, as well as lapses in memory and overall depressed mood. In fact, 3% of all females in the United States suffer from fibromyalgia, and nearly 0.5% of men in the country suffer from this condition. Typically, patients with fibromyalgia are not relieved of their pain by local anesthetics or even pinpoint trigger therapy. This has caused researchers to believe that fibromyalgia is not a peripheral nervous system issue. It's not tears in the muscle or deteriorating muscle. However, it may be caused by differences in processing at the central level of pain. Research, as reported here, strongly supports this latter view. In panels A are functional magnetic resonance images from controlled patients. In B are fMRI images from patients with FM. And C is the difference between these two fMRI images. Overall, what we see is that when patients with FM are presented a stimulus that typically will anticipate pain, will signal that pain is coming, they have a decrease, shown here in this blue differential image in C, in particular regions of the central nervous system, mainly in the VTA, the ventral tegmental area, as well as the primary sensory cortex, S1. These areas, particularly the VTA, are important centers releasing dopamine and GABA in response to reward processing. And therefore, this evidence strongly supports that fibromyalgia is not a condition of sensation, but a condition of processing, perception. Before discussing chapters 9 and 10, we really want to take time to really differentiate between sensation and perception. They are not the same. Sensation is the detection of your environment or the changes in your environment. On the other hand, perception is realizing these changes, being made aware of, making sense of all the things that are going on around you or in you. Whether we're talking about somatosensation, touch, or nociception, pain, touch related to injury, another key difference is that sensation is non-subjective. It's merely focusing in on those detectors, those receptors, and the actions or inactions of those receptors. Whereas perception is highly subjective. What's painful to me, may not be painful to you at all. Yet, even though it's highly subjective, we attempt to make and use scales. Has your doctor ever asked you how painful is it on a scale of 1 to 5 when you go in with some type of ailment? And we report some scale of 1 to 5, how painful it is. Well, should we really be interested in actually measuring the sensation, which would be relatively hard to measure at a gross level, but perhaps we could get to the detection issues, the receptor issues. On the other hand, perhaps the perception of that pain, as seen in patients with FM, really give us an idea of the etiology, the origin of the condition. Lastly, sensation requires receptors to capture changes in our environment, whereas perception requires processing by the central nervous system to allow us to make sense of those detected changes. Hopefully this makes sense. Hopefully you can have a good idea, of the differences between sensation and perception. because chapter 9 and 10 implicitly deal with both. Chapter 9 is focused on somatosensation, and chapter 10 is focused on nociception or pain. Well, pain in itself, without the nociception, is merely perception. But nociception brings in the sensation, the sensory components, those detectors, those unmyelinated fibers that are going to go through the anterior lateral system. I say that all to say, to kind of reinforce that you really need to have at least 6 points of clarity when reading and divulging or delving into chapters 9 and 10. Here they are as follows. Number one, no matter what system you're discussing, somatosensation or nociception, you need to know where are the detectors? What are the detectors? Where are they located? Number two, how are these detectors structured? And how does this structure allow them to capture information about the environment? What neural paths or tracks or bundles of axons do these detectors send sensory and or painful information to the central nervous system? Fourthly, where do these tracks decussate? Do they decussate in the central nervous system? This will be important when actually addressing certain debilitating disorders. Fifth, what nuclei or nucleus of the thalamus are involved for the type of sensory information? This is key because it's going to tell us how this information is further processed. And lastly, where does this information end up? And the way I ask that question is, where does perception begin? If perception begins in the cortex, what region of the cortex is important for somatosensation versus nociception? These are 6 key points of clarity that you really need to make sure you understand very well in reading these chapters. Some key items, and I'm going to go through them very quickly, is that you definitely need to understand the inner workings and anatomy and the structure of the dorsal column medial lemniscal pathway. Be able to contrast that to the trigeminal thalamic tract, as well as compare that to the anterior lateral system. Lastly, the two last items, understand about regulation and really that processing that happens on the central level. How does the CNS regulate the perception of pain? And how does it arise for giving the sensation or the perception, of phantom limbs and phantom pain? While the goal for week 5, similar to week 4, is singular, it is rich. By the end of this week, in reading chapters 9 and 10, you should be able to evaluate the functional consequences of the differences in neuroanatomy and neuroconnectivity for somatosensation and nociception. If you cannot do this after doing the assigned activity for this week, let me know. I'm here in my office hours and I'm here to help you. Outside of those, we make an appointment. With that, I say have a great day and take care.